Okay, hi everyone who might be joining us. I'll just give Ed a minute to let people join the stream and then we'll get started. So, hi everyone out there. My name is Eleanor. I am a university student studying chemistry and maths, and I'm also a guide leader. And today I'm going to be teaching you all and doing some experiments about bubbles, but also about water and some of the properties of water that allow us to make bubbles. Yeah. So all the experiments that I'm going to be doing today are live, so it's entirely possible that some of them might go completely wrong. But if that happens, we'll just have to try again. And if you're doing them along with us and they go wrong, just give it another go. So everything should work, but real science is a little tricky sometimes and things don't always go how we're expecting them to. So yeah, the experiments that I'm doing today, I will show you how to do them if you want to follow them along at home. But if you don't want to, then you can try it later or you can just watch and see what happens. So let's get started. So the first thing that I'm going to be doing today, experiment number 1, is demonstrating some of the properties of water that allow bubbles to happen. So if you look in the camera that I've got showing in my hands, I'm going to fill up this glass with some water and show you a couple of cool tricks we can do with this. So if you're coming along with me, you want to fill up your glass of water so that it's completely full and then just a tiny bit more than that. It shouldn't be overflowing. Oh, the other thing is make sure you've got a tray and maybe a tea towel on hand, just in case there's any spills, because I've had some when practicing this. It's a little bit messy, but that adds to the fun. So we're going to try and fill this up. And if you have a look at it, you should be able to see that the water has formed a kind of dome over the top of the glass. So the glass is completely full, but then the water, oh, it's escaping a little bit here. The water is slightly bigger than the glass is. So that's interesting on its own. But now the other thing we can do with this is I'm going to stick my finger inside the glass of water. And if you want, you can write in the chat and tell me what you think is going to happen with that. So make a prediction for me about what will happen if I stick my finger inside this completely full glass of water. Now, what you might expect to happen is that because the glass of water is completely full and there's not room for anything else, if I stick my finger inside it, the water is going to spill all over the place and go all over the tray. Now, I'm going to wet my finger just to be on the safe side that this will definitely work. But if you watch, if I stick my finger inside the water, oh, it's spilling a little bit, but not as much as my finger. My finger's, fairly big and a tiny bit of water spilled over the edge. But if I put my finger in just a little bit, it shouldn't spill too much. Yes. Now, also, if you have a very close look, you might not be able to see on this camera, but if you're doing this at home, you can have a look. If you dip your finger into the water, as you pull it out, the water kind of sticks to your finger a little bit as your finger leaves the cup. Now, all of these things, this dome, and the fact that I can stick my finger in the water without spilling it very much, the fact that it sticks to my finger as I pull it out, are due to a property of water called surface tension. And that's really important for bubbles. So I've written it down on this piece of paper here, so you don't forget it. We've got surface tension here. I'll leave that there. It might get a little wet, in which case I'll have to move it, but surface tension. And what's going on here is that water, while it might look like it's all one thing, we've just got one chunk of water here, what's actually happening is that water is made up of tiny, tiny little pieces, which you might have heard of. They're called molecules. And the molecules in water in particular, not in everything, but specifically in water, are all attracted to each other, just like the way that your magnet is attracted to your fridge, so it sticks to it. And that means that all the molecules inside this glass of water are sticking to each other just a little bit. It's not loads, because obviously I was able to stick my finger in there and the water was able to move out the way so I could get my finger in there. But it's just enough that at the top of the water, you get this dome, because all of the water molecules are clinging onto each other and they don't want to spill over the edge. They're like their best friends and they want to stay together. So when you fill it up, the water sticks to each other and you get this dome. And when I stick my finger inside the water molecules again stick to my finger and they go inside, when I stick my finger in the water, they stick to my finger and they cling on. So instead of spilling over the edge, the water is sticking on there. And the same thing when I pull my finger out of the water, because the water molecules are all sticking to each other. As I pull my finger out, it just sticks to my finger just a little bit as it comes out of the water. Now, hang on just a second, my dad's trying to interrupt the Zoom call. Yeah, we're okay. Now, we're going to try this again, but this time I'm going to put some soap, so just some ordinary washing up liquid soap, on my finger and see what happens this time. I'm going to cover my finger. It's going to be very nice and sticky, all in some washing up liquid. And this time when I put my finger in, the water should definitely spill over the edge. It might not be totally clear, but the water is spilling over the edge. Now, the reason that this happens this time is because soap, like washing up liquid, disrupts the surface tension. It's kind of like, if we say the water molecules are all friends and they all want to stick together, soap is like a bully, and it comes in and it breaks up all the friendship and the water can't be together anymore. And that means that the surface tension is broken. So when I stick my finger in and it's covered in soap, the water will start to spill over the edge. But this is also really important because that is what allows us to make bubbles. So if I take my straw and I'm going to stick this inside the water and I'm going to blow some bubbles for you. They might be a little bit better than they would normally be because we've got some soap in here for my finger, but let's see what happens. Now, as you can see, it's forming some bubbles inside the glass, and the bubbles rise up to the top and they stay on the top of the water for a little bit, but then they just disappear straight after. And this is because when we form bubbles, all that a bubble is a bubble is air, which happens to be surrounded by water. And technically, it doesn't even have to be water, it can be anything. So you can call a balloon a bubble, for example, because it's air surrounded by something else. And when you blow bubbles in your glass of water, or maybe you've done this with your orange juice and your parents have told you off for it, that always happened to me, you get the same thing where you have the air being surrounded by the water. But as soon as it gets to the top, because of this property, the surface tension where the water all wants to be friends, the water doesn't like being stretched out away from its friends, and it just pops back into the nice dome shape that we had before. But if we add soap to the water, like when you're doing your washing up after dinner and you add dishwasher soap, then you can get bubbles because the soap is disrupting the surface tension. And what you end up having is, I've drawn a picture of it, so hopefully you'll be able to see this. The soap forms a layer. So you have the water, but the water is surrounded by two layers of soap, one above it and one below it, and the air is trapped inside. And because the soap breaks up the surface tension of the water and it doesn't want to be friends quite as much, you can get these bubbles that, as you'll have seen if you've ever blown bubbles before, can float off in the air on their own. And in this case, instead of it being the surface tension that breaks the bubble, what happens is the reason that your bubble will eventually pop is that the water just evaporates away and then we've got nothing left to form the bubble and it just disappears into the air like everything else. So the second part of this experimenting is what we're going to do is we're going to try and make some super bubble solution and see what we can do with it. So we'll move this out of the way. We'll move the soap. And we'll carefully move my glass of water, try not to spill anything. And we're going to try and make some super bubble solution. So what you will need for this is you'll need some water, you'll need your washing up liquid or your dish soap. And then the final special ingredient, you can do it without this, but this will make it better, is glycerin or glycerine. And this has the magic property that it helps stop the water from evaporating. So our bubbles will last much longer if we add some glycerin to it. So we're going to add, I'm going to use proper measuring cups, but if you don't have any of these, you could just use a mug. The important thing is just that you get the same ratios as me. So we're going to add 2 cups of water, first of all. And our second one. And now you're going to need to add 1/3 of a cup of washing up liquid. So if you're just using a mug, then a way that you can measure out 1/3 is by trying to imagine dividing this into 3 chunks, and then you just want to fill up 1/3 of it. Because I'm using measuring cups, I'm going to use a separate cup, and this is a third of the cup, so I know that it'll be accurate. It doesn't matter too much if you don't get the amounts completely exact, but as long as it's pretty close, then you should get something good. And you can always mess with it a bit. If you've got too many bubbles, add a bit more water. If you have not enough, add a bit more soap. Slowly adding my soap in. Okay, I've got my soap here now. I'm going to pour this in. And then get a teaspoon. Put that in. And mix it in so that the soap and the water is mixed together. And finally, you want that secret ingredient, you want the glycerine. And you will need a teaspoon of this. So I'm going to use a proper measuring teaspoon, but if you've just got a regular teaspoon like this one, that will be totally fine as well. Or if you want to kind of guesstimate it a bit, that would be okay. So I'm going to pour out 1 teaspoon of glycerine and add that in to my bubbly solution. Okay, mix that all together. Now you might be able to see there's actually already some bubbles forming on the surface just naturally as I stir this in, because it's that good at making bubbles, it just wants to already, just by me stirring some air in. So now we can start with the fun stuff and we can make some actual bubbles. So if I get my straw like I did before and I blow into it, we get some bubbles, which you might be able to see if I tilt this up here. And unlike with the glass of water, the bubbles are going to stay for much longer here. See, they're not disappearing unless even if I pop them, they really don't want to go. These bubbles really want to be here. Now we can also try, if you have a bubble wand, then you can use this, or you can try making your own bubble wand out of a piece of pipe cleaner. So this is what I made earlier. I can show you how I did it. So you get a piece of pipe cleaner and you're going to turn this bit one end into like a circle and then wrap that bit of the pipe cleaner around like that. And then you've got your own bubble wand. It won't be quite as good as a normal one, but it'll do for now. And if you dip that inside your bubble solution, if I bring this up to the camera, you might be able to see. If I kind of twist it, you can see a kind of shrink. So we've got some of the soap has attached. So we've got the sort of sheen of a bubble. And then if I blow on it, are we going to get, no, it's not giving me a bubble. As I said, it's not as good as a bubble wand. That's not there. See if I can make it work if I try with a bit of a smaller bit of pipe cleaner. I've done it a bit smaller there. If I blow on it, is it going to work? It might not work. Oh, there we go. I got a bubble, but it popped. So try it with yours. See if you can make a bubble better than I can. Now, another interesting thing that you can try with this pipe cleaner is if instead of a circle, if you make it into a kind of square shape, what happens? So again, if you've got any predictions, have a go at writing them in the chat and see what you might think will happen. What shape will the bubble be? And instead of being a circle, if I try and make it into a square or a triangle or any other shape that you fancy making it with. My hands are getting very soapy doing this. What will happen? Okay, we'll see if we can get a bubble. I don't know if you could see that over Zoom, but I didn't get a full bubble just like before because my pipe cleaner wand is not very good. But what you could see happening was that we were starting to get a dome forming. So we didn't get a square shaped bubble, got a round bubble, just like you would with a round stick. Now, the reason this happens is because the surface tension, just like we got before, we want to make it, the bubble wants to be like a space that takes up like, it ruins the surface tension as little as possible. And if we have a circle shaped bubble, this doesn't ruin the surface tension for the water anywhere near as much. And the other reason is, remember, we've got the air in the middle of our bubbles. I'll show you that picture again. Hold it up here. We've got the air inside the middle of our bubble. And air is going to push out equally on the soapy water surface of the bubble in all directions. So even though it's coming from a square shape, it's going to come out and it's just going to go out in every single direction. And so that means that we get a sphere. Just like if you blow into a balloon, even though where you're blowing from might not necessarily be a kind of circular shape, depending on how you're pinching the start of the balloon, the air will go out and it will expand in all directions. So we end up with a nice sphere. Now, another interesting experiment you can try is if you get a flat surface. So you could try this with the lid of your box, or if I'm going to use a plate, because that works a bit better than the lid of my box. Move this stuff up. And we're now going to pour some of the bubble solution out into our plate. So we get a very thin surface covering it. Let's see how well I can do this. This is where it gets nasty, so just watch out. Okay, ooh, that might be a little too much. We'll see how that goes. So I've got, you possibly can't see it, but there is a tiny bit of water in the bottom of my plate. And if I blow with my straw into the plate, yeah, an absolutely massive bubble. Look at that. That's a good one. We can get the big ones because we've got the special bubble solution that we made up. Now, a cool trick you can do with this, I'm going to get something sharp. So I'm using cocktail sticks, but it would work with a needle or scissors or a pen or anything else that's a bit pointy. Now, you would think if I stab this into the bubble, that the bubble would pop. But if we cover it in water, I'm going to wet my cocktail stick and then put it inside the bubble. Look, I don't know how well you can see that. Ooh, let me try and bring this a bit closer. We have the bubble and the cocktail stick is going inside it. And the bubble remains completely unbroken. But if we try it with the dry end of the cocktail stick, boom, it pops straight away. And the reason that that works is because when we have the water on our cocktail stick, the water is completely coating the cocktail stick. So the cocktail stick, the bubble itself is protected from the cocktail stick by this layer of water on top of it. So when this layer of water enters into the bubble, it goes through these layers of soap, water, soap, and into the air layer. We have water is what's actually in contact with the soap and the water. So the soapy, watery layer outside the bubble isn't broken because we've got, as far as the bubble is concerned, all it can feel is water surrounding it on all sides. Because just as if you were to like dip your finger in a glass of water, you have that layer of water completely protecting the bubble from the sharp object. But if you do it with the dry end, then it's just going to pop straight away. So see if you can try and do this and try and different materials. You could see how thick a material you can do it with, see if it will work. I'm going to try and see if I can do it with my finger, which I've not done before. So we're going to see if that will work, if I can still get the bubble not to pop if my finger is wet. So I'm going to blow another big bubble. Dip my finger in some water and see if this will work. I think, no, my finger's too fat, so that doesn't work. So you can see if you can find anything between size of my cocktail stick and my finger that might be able to go inside the bubble successfully with it being wet. Remember, you've got to wet it first. If it doesn't work, try dipping it back in water again because you might have not got it wet enough the first time. Some other experiments you can try with this, you can see just how big a bubble you can blow. Because we've got our like super bubble solution with the glycerin inside it, the bubbles last much better than they would normally do. So see how big a bubble you can get. You can also see if you can try and do a bubble inside another bubble, which I'm going to try now. So I'm going to blow a big bubble first of all. I might not have enough solution. Let's get some more. There we go. We've got a nice big bubble. And if I wet the end of my straw, just like we did with the cocktail stick, that might, oh no, the bubbles popped. Let's try that again. See if we can get. So at the moment, I haven't quite got my straw inside the bubble because I can see, you won't be able to see on Zoom, but I can see that the shape of the bubble is clinging to my straw and going around it. So let's see if I can get it to, oh no, it popped. See if you can do better than me. It's definitely possible. I managed to do another cool thing by accident when we've got two bubbles next to each other. Let's see if I can get it inside. Try one more time, and if it doesn't work, I'll give up. But you can try it at home and see if you can do a better job than me. Okay, so we're getting, there we go. Aha, I've done it. Get my camera a little closer to see if that will make it easier to see. There we go. So you might be able to see that inside this bubble, there is a second bubble inside it. So what I did there was I got the straw wet, and I stuck it through kind of the middle of the bubble. So when I tried to go in at the bottom, it kind of clung to the bubble. So as soon as I started blowing on it, I just blew away the bubble. So if you go in, it's popped, but the middle one is still there. Yeah, see what you can do. See what you can create with the bubble solution. If you make anything really cool, then you can send it in to us. You can get your parents to email it to us or send it to us on Facebook. And yeah, have a play around, see what you can discover about bubbles and about surface tension. Thank you very much.